Okay, so here we are trying to discuss today. The concept is all about circuit breaker concept. So what is the circuit breaker? What we are going to do with service circuit breaker, we will try to understand in today's session. And I'm telling you, let me just give me a moment. Circuit breaker, what we are going to do with circuit breaker, why Spring Cloud or Spring Boot architect framework provided that component as part of the microservices architecture. I mean, what is the importance of circuit breaker as part of microservices architecture? We will try to understand. Okay. So generally, circuit breaker is all about, for example, yesterday we written logic like user communicated with the order. Similarly, user communicated with the product service. I mean, user means user microservice. User service communicated with the product service. Sorry, order service. We written for this logic. What we written? We written pin client, and we written somehow user services is able to connect it with the order service. We are able to communicate with order service from the user microservice. Similarly, we implemented logic for the payment service also. So like that, we can payment service. Okay. So like this, we implemented yesterday. We were able to send the request. We were able to receive the response from the producer application, from the opposite application, right? Now, as part of this communication, assume there is a chance of the producer application, what you are trying to communicate with, okay, whatever the application you are trying to communicate, whatever the microservice you are making the communication, okay, assume this is what being down. Down means this service is not available. This service is not responding. This service is down. So no instance is available. All the instances are down. All okay. Somehow the reason is whatever it is, due to some exceptions, all the instances went down, or maybe somehow we stopped this service. Okay, due to any other reasons, we can completely stop this service. Some reason this service is not responding. This service is not responding. Which service? The opposite application or the producer application or the producer service is not responding. Then what will happen immediately? When you are sending a request again, in this case, what is going to happen? It will send request to order service. It will try to connect, establish communication with the order, but order is not available. After some point of time, you are going to get some internal server error, something like that. You are going to get the error pages or error messages, right? So whether it is true or not, we will try to understand first. What I will do here it is, let me start config server, gateway, service registry, and I'm starting user service. I'm not starting order, but I'm trying to make a communication or I'm sending a request. What we did yesterday, yeah, user versus order. So I'm sending request from here. So in this REST service execution, what is happening? We are making call from user microservice to order microservice, right? Finally, we are sending some data from user to order. So the logic is executing at order, and you are getting a message as order created successfully when order microservice is available. When order microservice is up and running, its health status is good, right? So now in this case, what we did, if you observe here, I started only, okay. It's all cache problems, editor problems. If you see here, when you started the service, pin client factory beans for order service URL not provided, Eureka client users something like, payment service URL not provided, something, whatever the pin clients we written yesterday, leave about. It's not our concept right now. It's all, just go through the logs. It will give a lot of other knowledge also. Fine. Finally, your application is started. Now in this overall architecture, I'll open this one also. What Eureka server, localhost :8761. Okay, if you observe here, what are the microservices are up and running? Only user. Order is up and running. Are we started order? No. Are we started payment? No. So that means some reason it is went down, or we stopped intentionally, or whatever it is. Simply the producer application is not responding. That is what the use case here it is. So in such case, what is going to happen? For example, I'll start the order and then I'll stop it. Order is available right now. Okay, this is also cache problem. Yeah. Order service. I can do add one extra line. You have to do Maven update. That will also resolve this issue. So this is how, even once you join into any microservices application development also, you will develop config server gateway service registry initially. Okay. And after that, once you started working on the project, you will never ever touch config server service registry. Okay. As well as Eureka, gateway, all these applications you will never ever touch. Simply you will start them and you will start always writing logic about your respective thought. Okay. 30, 40, 50 microservices, what you have related to business requirements. There you will always write down the logic, creating the orders, making the communication between one service to another service. This is the kind of logic you will write down always. This is all one-time work. See, config server now you are going to touch in future anytime. We will never ever touch, right? And we will simply, whenever you created a microservice, what you will do? For example, assume you created today 4th microservice. What you will do? Simply you will give config server URL inside the application.properties. But you are not doing any change in the config server level. So that means in future, you are keep on adding the new microservices in the same project level. Are you going to touch config server most of the times? No, right? Very rare case. So that is what I'm trying to say from day one onwards, microservices. Microservices is all about a topic of architecture. What is the components we are learning is all about only one-time work. Only couple of things you are going to use on daily basis, but the remaining service registry implementation, all these things are all one-time work as part of your project. But at the end, finally, you should be confident with the regular core logic, how to write down Spring Boot, core Java knowledge, as well as services communication, REST services creation, REST services consumption. In such area, you have to be very strong. Okay, so now let me send the request. Order is available. Okay, internally by using Fin client, we discussed yesterday. We used it internally, Fin client. So Fin client internally going to be connected to service registry, and it will ask, okay, how many order services instances are available? Then service registry will say like, total how many? 2 instances available. Then internally service registry I will apply default load balancing, and it will find out which is having less load out of 8005, 8006. So then out of these two, one instance will be selected and the request will be routed to here. Finally, your request is executed on that instance. Your logic is executed and you will get response from that instance to your client level. Fine. So you got the order created successfully, 200 okay like that. You got the every time successful response. Now the scenario here it is some reason, okay, whatever the reason it is, this microservice is not responding. That means as you assume this is stopped some reasons. Okay, accidentally or whatever the reason it is. Now order service is not responding. Order service is down. Now in this case, if I am sending the request, Fin client is looking, asking the service registry, do you have information of order service or not? But order service information is available with service registry. When you are stopping, automatically that information also removed from the service registry. You know that, right? So even if you see here, what is this? Down. After 1 or 2 minutes, even you will not see this statement also. Immediately it is showing at least down, and after a couple of minutes, you will not see at least this row also. This is also disappeared. So nothing but finally, order service information available with the service registry? No, because order service health status is up or down? Down. So that's why. Now let's send the request. So what happened here? As expected, you got 500 internal server error, and it is saying like Fin client exception, service unavailable. So which service unavailable? That respective order service or the respective producer service, in case, in our case, order service. So it is saying like service is unavailable. So that's why which service, order service when client, okay, create order is unable to execute. That is what the error they are giving here. It is 503 during calling to the order service. Okay. Load balancer doesn't contain an instance for the service, order service, right? That is what true or not? So if you go and see here, okay, after 1 or couple of minutes, this will be go away. So that means here, that is what they are saying. Internally, load balancer is not able to find out at least one instance of order service. So at the end, you got result as 503. It's service unavailable or internal server error, 500 internal server error, a generic error message. But in this case, instead of displaying these kind of messages, for example, instead of getting this kind of responses, I want to make sure, okay, a kind of dummy response, okay, some kind of meaningful response message, even though service is failed. So that means whenever service health status is good, user versus order, when service health status is good, I'll get always expected response, dynamic response, right? Dynamically, I'll get the response because the opposite service is available as expected. When service is not available, instead of getting hello. Okay, now the point here it is, in microservices architecture, we will not do one service to one service communication 1 or 2 times. We will do n number of times, hundreds of times. We will communicate with different microservices. One microservice will communicate with 5 to 6 microservices. Similarly, other microservice will communicate with other microservices. Like that, it's all about you are going to do hundreds of times. Okay, you are going to write down the logic implementation for consuming the REST services from one microservice to another microservice hundreds of times. So then, how we are going to manage the failures? This is what the failure or not. Now in this case, the service communication is a failure or not. So whenever you are doing the frequently service communication, one service is calling another service, like integrating the REST services or calling the REST services or consuming the REST services, then how you are going to handle the failures of the service communication. So that is what the point about the circuit breaker. So when everything is good, you are getting 200, okay, and as expected dynamic response you are getting. But when something is failing, so we should not make sure the application is, the entire microservices architecture is broken, or you have to manage those failures with some couple of, okay, meaningful response. At least you have to make sure some meaningful response, or you have to return at least a dummy response. Okay, so in failures case, at what time you have to make sure this? Only in failure case. If it is everything is good, if everything is good, are you going to send this response? No. If everything is good, that means health status is good, service is available, then you will get always the actual REST service response. Order created successfully, something like that. The service layer will be executed, repository layer will be executed, and whatever the logic you written, that should be written. But somewhat service is failed, you have to always manage with somewhat a meaningful response message, something like service is not available, wait for some time, or something like please take this data, meanwhile continue with other operations, something like that. You have to make a response back to the consumer application, to the client application or consumer application. So that is what the meaning of circuit breaker. Now when it comes to the circuit breaker, have you heard anywhere else circuits? No, in your education time, circuits. This concept they taken from that circuits only. What you know, what we at least hear, electronics point of view, electrical circuits, right? You don't know circuits, even I don't know. So what is this? Generally, I mean, people who are came from electronics or whatever background, they will understand. So generally, this is all about a circuit, right? So you are making a circuit, somewhat you are passing the power or whatever it is, energy in between one thing to another thing. Yeah, this is what I think. Okay, so this is one way. Second point is, in our homes, when people are doing, not only, most of the places nowadays, when they are doing the electrical works, nowadays they are applying one, I don't know what they will call it as. So assume there are scenarios maybe you observed. When high power came, in our homes they are arranging nowadays one kind of component, I forgot that name. Not only fuse, they will apply some kind of MCB. Yeah, yes, exactly. MCB. What will happen? When high power came, what will happen? Your MCB will be, that word there we will use a word. What it is? Tripping. Tripping, right? So your MCB, that switches will be tripped to down. That means what's happened? It identified some high voltage came or some abnormal situations came. Okay, then immediately what MCB is doing? MCB is immediately tripping. Tripping means it's stopping the current flowing to all your home electronics. I mean, all your home circulation. So it is stopping. It's not passing power to all your home. So it is immediately stopping. It is immediately tripping. When it is tripping, when it observe abnormal situations in the power flow. If it is going as expected, regular flow, okay, within the range of watts or whatever it is, it will never ever trip. But all of a sudden, high power coming, or maybe high voltage, or whatever is low voltage. So it's all about abnormal power flow is happening. Then what MCB is doing? MCB immediately tripping down. So that means what is the advantage with that? What is the advantage that? Have you observed at least this behavior in our homes or in our offices, wherever it is, right? So what is the advantage? It is protecting all our home electronics, right? If you don't have that, what will happen? In earlier case, before 20, 30 years back, we don't have this kind of technology. What is going to happen? Whenever power, okay, rainy season came or high voltage came, it will affect directly to the TVs at the time, whatever you switched on. Okay, maybe the ceiling fans or whatever it is, the high power will be affected to respective refrigerators, TVs, as well as ceiling fans and everything. Then what will happen? Your TVs will be, okay, destroyed. Internally, the wiring circuit will be failed. Similarly, refrigerator circuits will be failed. Similarly, ceiling fans, wiring will be failed or whatever it is. So have you seen, have you know all these things? Can you close that? This useless fellows not closing door also. Staff. Sorry. Okay. So you know that. At least you know that, right? When MCB is not there, this is what going to happen, right? So now if MCB is there, if it is stripping, why it is stripping? To protect all the other electronic items what you circulated, I mean what you given the wiring point of view, right? So almost the circuit breaker concept, whatever we are going to discuss, they take an idea from that there only. Okay. So when I just gone through the earlier, what is circuit breaker and all, they taken same idea what we used to do in all our homes point of view with respect to MCB tripping point of view. They taken same idea with respect to circuit breaker design pattern. Okay. So now, for example, if MCB is there, it is tripping means it is protecting all our electronics, home electronics. It is not affecting to any electronics because why? It is immediately stopping the power. Okay, power passing to the all electronics. So it is the circuit is open. The circuit is open. That means tripping. So it is not passing power to the any other areas. Similar way, here also the circuit breaker design pattern we are going to use somewhat by using the idea from that only. So what it is, let's try to understand. And I will tell you one more thing, guys. This whatever the topic we are discussing right now, I'm saying like most of the times no servlet. Okay, sorry, microservices architecture will use the circuit breaker concept, what we are discussing right now. That means it's very less importance, I can say, because in my current project, we are not using, even in previous projects also, we are not using the circuit breaker. The reason is, I will tell you why circuit breaker will not be used, what is the things and all. But as part of, see, solutions will be, there are a number of solutions for one problem. What solution you are achieving, what solution you are using is up to our choice, up to our project customization, up to our okay, ideology, whatever it is. Okay, so why circuit breaker will not be used in most of the microservices architecture, we will try to understand. My point here it is, why I am saying this, understand what you know from today's class. We will see the result. I'll try to simplify it. One example. But if you are not understanding also, don't worry. It's not being asked in most of the interviews. Okay. And it's not being used in many of the applications also. But what will be used in the failures scenario? What is the second solution or alternative solution? In case if you are not using the circuit breaker, I'll tell you that. You already know that. Only thing is I'll tell you how to do that, what to do that. Okay. So if you see here, yeah. So with respect to failures point of view, what is going to happen here? It is, I'll open. Don't worry too much about all this. Okay. No, this is not visible properly. Service A, service B, service C. Yeah, this is what somewhat good only. Yeah, if you see here, that is what the problem here it is. This is what we are discussing. When service failures are happening with respect to one service to another service, how we are going to manage that. So yesterday one person is asking cascade failures. This is what the meaning of it is. So when A service is calling B, B is calling C, some way one of the one of the services not responding, then what you are going to do is all about the circuit breaker design pattern. Okay, so here the solution point of view they are talking. When A is calling B, B is calling C, it is waiting for some time. The response point of it is waiting for the some time. But D is not responding, then circuit breaker will be open. Circuit breaker is tripped. See, they are using a terminology called as tripping here also. So the same kind of point of view. I'll circuit breaker. Yeah. If you see here this image, you cannot see, right? Even I can open on one more. Yeah, if you see here, so circuit breaker pattern, the concept is the architecture, I mean, the definition of circuit breaker or the circuit breaker design pattern is all about around this diagram. So what is going to happen here? It is circuit is closed, circuit is open, circuit is off open. So what is the meaning of circuit is closed? What is the meaning of circuit open? What is the meaning of circuit off open? I'll try to understand this scenario. I'll try to explain it. See here. First thing is service 1, comma, service 2. Okay. So this is what we are making the communication. Service 1, service 2 communication. Here we are applying a circuit. We are making a circuit. Okay. So that's what. It's all when you are talking about the MCB also, the power coming from where? Outside of the transformers, right? Power transformers to your MCB level. And MCB level, MCB is passing via MCB. I mean, the power is passing to your home, right? MCB is always monitoring the power flow. Any abnormal situations, Your MCB is getting tripped always in your homes every day, every second. No, right? Until and unless it is observing the abnormal situations of the power. If it is low voltage or higher voltage than the regular supply, then your MCB is getting tripped. So same point of view here also. What is the point here? It is this circuit closed, open, half open status here it is. Whenever I'll do like this. Assume this is a circuit. Okay. So when service is making a call to service 2 and service 2 is already up and running, everything is good. then you will get the response as expected, like order created successfully, all this point of view. So in this case, when both services are enabled to make the communication, opposite service health status is up. Okay, I'll write on this in this scenario. Health status is what? Up or down? So in this is what the important right now. This is what important role now. We are depending on this service response with related to circuit breaker design pattern. Now in this case, S2 health status is up or not? First use case, up point of view. So what is the circuit breaker? Circuit breaker will not enter into the picture. When health status is up, circuit breaker status is closed. That means circuit is always by default in the which state? Closed state. Circuit is always in the closed state. Circuit is always in the closed state by default. When the opposite service's health status is up. After some point of time, this health status went down. So that means you stop with this service or whatever the reason it is health status is down. Then what will happen here it is, when you are sending first time a request, you got somewhat, okay, timeout. That means service is not responding. Second also, you sent something like that. Second time also, there is no response. Then what circuit breaker will do here it is, immediately after monitoring, see how many calls has to be monitored, how many failures has to be monitored, that configuration we will do that. That configuration we will do that. So after monitoring couple of failures, after monitoring couple of failures of service response, okay, then circuit will be open. Then circuit will be open. Okay, then circuit will be open. So that means, now what is the status of circuit in this case? Open. So now circuit entered into the picture. Why it is entered into the picture? As of now, circuit is closed. Circuit is not doing anything because the communication is happening healthily. There is no problem. So that's why circuit is always monitoring. Health status is good, coming response as expected. Then circuit is always in the closed state only. But when it comes to failures, now all of a sudden, service 1 not getting response from the service 2. Service 2 health status is down. Okay, service 2 health status is down. Service 2 is not responding. Then what circuit breaker is doing? After monitoring 1 or 2 calls in between S1, S2, service 1 to service 2. After 2-3 calls also service 2 is not responding. Okay, then circuit is entering into the picture. Then circuit status is becoming as, yes, now circuit is open. Why it is open? What is the advantage of opening this here? It is, I'll tell you. Once the circuit is open, what it will do is, it will apply a fallback mechanism. Okay, a fallback mechanism. So with this fallback mechanism, what you can do here it is, I told you already, we are going to manage the response with some meaningful response in case of failures. Instead of sending this kind of overall stack trace, if I am sending something like order service is not responding, okay, please have a look, or please contact to the so and so team, okay, or wait for some time, we are doing some kind of work, or maybe whatever it is. If you are writing a meaningful message here, meaningful response, order service is not responding, please reach out to respective team or whatever it is. Okay, if you are maintaining here, then that response will be forwarded back to the client. That means the consumer application. Now fine. Keep on, it is fallback mechanism point of view, it is sending that meaning, okay, that fallback response. Whatever the response we configured, that will be called as fallback method. We will define some fallback methods. So when fallback methods will be executed now? In regular case, fallback methods will be executed. No, right? Because circuit is always by default in the closed state. Why? Service 1, service 2 both are healthy. They are able to communicate as expected. You are able to see everything as expected. When service 2 is down, after a couple of okay, response failures, what will happen? Circuit status will become open. When circuit status became open, then immediately fallback mechanism coming into the picture, and you will get this response back to the client level. So this is how things will happen. That is what they are trying to explain as part of this circuit breaker diagram. Now understand, when circuit breaker is closed is request failed with the threshold limit. So by default, what is the first status? Closed. Okay. When it is going to open to the, when the circuit will be open to the, sorry, when the circuit status move to the open, they are saying multiple requests failed with the threshold limit. So the limit is nothing but simply you are saying like, okay, observe 2-3 service requests. I mean 2-3 service requests. If 2-3 service requests are failing, then move circuit breaker, okay, circuit status to open. Then you are opening the circuit. So it will observe couple of failures. That is what the threshold limit. That how many calls has to be observed, whether it is 1 or 2 or 5, we will configure via properties. Okay, that is what we are going to do in the implementation step. Then circuit is open. Then circuit is open. When circuit will be open? When requests are getting failed. When requests will be getting failed? The opposite service is not responding in such case, right? Then circuit status is open. Now in this case, what is the half open state? What is the half open state is simple. I told you one point. Circuit is always, circuit breaker design pattern in the back end, always monitor health status of the opposite application. That means service 2. Circuit breaker, what it is doing? It is always keep on monitoring, the circuit is always monitoring health status of service 2. Is like, it is always in the back end, it is always checking is health status up or not. People who came from electrical background, they know all this half open, full open, all these things. Even though you don't know, leave it. Don't worry about all these things. Simply, I'm just telling you. Now, what it is happening here, it is circuit breaker internally, the design pattern implementation, what it will do is, it is verifying health status of service 2. Now, after a few minutes or after a couple of, minutes, S2 status came up. That means S2 is available now. Now, at that time, what is the health status of S2? Up. So before that, S2 health status is close. Sorry, S2 down. S2 health status is down because S2 is not available. So what it is doing from this half open is, if you see here, so in the circuit, once it is opened state, once it is moved from closed to open, when failures are happened, immediately what it will do is, for the monitoring purpose, the circuit will open to the half open status. And from the half open, it will observe how many failures are happening. Keep on. Still failures are happening. Again, 2-3 service requests came. After moving to the half open, again, 2 requests got failed. Again, it will move to the open state. Okay, again for monitoring purpose, it will not do monitoring and from the which state? Open state. It will come back to the half open state and it will monitor still service is responding or not. No, it's not responding. After 1 more 2 service requests, then again it will move to the open state. Then again it will come back to the half open state. It will start monitoring. This time, all of sudden, okay, first request got success. Second request also got success. That means the response coming from the actual microservice point of view. Then immediately circuit will be moved to the closed state. For monitoring, see, when everything is somewhat initially requests are failing, immediately circuit is moving to the open state. Why it is moving to the half open state? For the monitoring of upcoming failures. Okay, I got 2 service requests. I observed like, okay, something is going wrong. Let me open circuit. I open the circuit. At the same time, keep on requests are coming or not. Obviously, client will send n number of requests. Keep on, they are sending the request. Then what I will do is, in the open state, I will move to the half open state and I will observe the 2 requests went from service 1 to service 2 is getting success or failure. Okay, after moving to the open state also, the 2 requests came from service 1 to service 2 is not responding by the service 2. Service 2 is not responding. Then what I will do? I will move to the again open state. It's like that. It will fluctuate between open to half open to open. But when again it will move to the closed. Now all of sudden service 2 is up and running. Service 2 is up and running. And at the same time service 2 started giving response back. Then from half open state, I will observe 2-3 calls getting success or not. Okay, this configuration also we will do. This configuration we have to do. After how many calls the circuit has to be opened, the circuit has to be moved to the half open state. All this configuration generally we will do. Okay. So 1, 2, something is success. Then I'll decide like, okay, couple of requests getting successful response from the service to now. There is no problem. Now let me close the circuit. Like that, internally the circuit will be closed now. Now again, service 1, service 2 is communicating with actual request and actual response point of view. But in this open, half open status, okay, after reaching to the some threshold, the response, what you can define some fallback methods response, and that response you can share it to the S1, like we are working on the S2 failure, we are looking into S2 or contact to so and so team, something like that. You can give a meaningful message or meaningful response to the client application. So who is taking care of sending this response in this scenario? In the failure status, executing this fallback methods, we will write down some Java methods. We are going to call it as fallback methods. So at what time these fallback methods are getting executed? When circuit status is closed or open? Open. When circuit will be open? When service failures are happening. When request response failures are happening. By default, circuit breaker status is closed. That means both the status, all the health status, all the communicated microservices are responding properly. That means until and unless service failures are not observed, circuit breaker is always closed. If it is observed any failures, then it is moved to the open state. And from open to half open, why it is moving? To monitor upcoming sequential requests are getting success or failure. Keep on getting failure. Then what it will do? It will observe 2, 3. Still failure responses. Then again it will move to the open state. Then again it will come back to the half open. Then again it will monitor. Okay, now 2, 3 requests got success response from the actual microservice. Then what circuit breaker will decide? Now the communication between service 1 and service 2 both are good. So let me close my circuit. So then it will close the circuit and the actual communication is going to start between service 1, service 2. So this is what the idea behind circuit breaker design pattern. So circuit breaker design pattern is bringing into the fallback methods, fallback mechanisms. Okay, in case of failures, instead of getting timeout errors, internal server errors and all, you are making a meaningful response in the failures point of view, specific to REST services point of view. So let's implement this first, and then we will discuss in case if you are not using circuit breakers as part of our current architectures, then how we are going to manage the meaningful responses with respect to service failures, service communication failures. We will discuss alternative solution. For example, what we are doing in my project, I'll try to give you. Okay, let's implement this first, what you are going to do. Now, for example, point number 1, I'm making user versus order. Now, where I have to do the code changes? User or order? Why order? See, I am the producer. You are the consumer. I told you like you can access my REST services. I given the details. I may available, I may not available. When I am available, what you will do, it's up to your headache. When I am not available, what you will do, it's up to your headache. How you are managing your failures. I am not available. What you will do is your headache. So that means you got the point now. So it's all about consumer headache. Consumer has to make sure meaningful solutions with respect to failure scenario. When something is going to, generally when you're making a plan also in our real life, what we will do? We will not think always about the successful scenarios. Sometimes we will think about the failure scenarios. Based on that, we'll make a backup plan after. Same kind of scenario here also. So here it's all about, you have to implement the circuit breaker design pattern with respect to user microservice point of view. Okay, producer is always may be available, may not be available. So what? The fallback mechanisms, the failure scenarios, how you are handling is all about with respect to consumer point of view, you have to do these things. So what I'm doing here it is, I don't remember all the properties. There are a lot of properties available. I'll explain one by one. And don't worry too much about the properties also. I'm telling you, even I don't know most of the properties. I cannot remember also. Okay, so I just provided in a high level point of view, what is circuit breaker, what you have to answer in interviews and point of view. When one service is failing to communicate with another service, what is that and all. how pattern works. Basically, it behaves same as electrical circuit breaker. Yes, this design pattern solution they taken from the electrical circuits only. This idea they got from the electrical circuits only. Okay, so when the application gets remote service failures more than a given threshold, what is the more than given threshold? We will configure that. Observe 3 failures. When 3 failures are happening sequentially, then circuit should be open. Like that, we will give that count. How many service failures we have to monitor, something like that. That is what the meaning of threshold here it is. Circuit breaker trips for a particular time period. So after this timeout expires, the circuit breaker allows a limited number of, that is what we discussed everything in a simple theory point of view. If those requests are getting succeeded, then circuit breaker will be closed and normal operations will be resumed. So if requests are getting succeeded, in case requests are getting failure, then circuit breaker status will be in the open and off open status point of view, and it is keep on monitoring for the failures. When success is happening, again circuit breaker is going to move back to the closed status. That is what they are talking about. What is closed? When both services interacting and up and running, that means both health status are good. Then what is the circuit breaker status? Up, closed or open. When both services are health status is good, both are communicating as expected, then circuit breaker status is closed. That is what they are saying here it is. Okay, open, as soon as some of the failures are happened, then it will move to the open. Half open is, so that's what I told you. From open state to it will move to the half open to monitor the API calls. Okay, to monitor the API calls, getting succeeded or failure or not. Somehow it is, calls are getting succeeded, then immediately half open to, it will move to the closed status. Okay, so closed is always, green means closed is always in the healthy condition. In healthy condition, circuit is always closed. That is what the point here it is. If everything is good, then it will move from half open to close. Okay, fine. What is resilience 4J is? Here it is. Okay, so this is all about an idea. This is all about a solution, an idea. So for this solution, there is a organization, I think, called as Resilience 4J. Okay, so this Resilience 4J organization provided solution. Okay, internally, someone else has to write down the logic or not to monitor these calls, all these things. So this logic is already implemented by the, okay, third party organization called as Resilience 4J. What is the meaning of resilience? An ability to recover from failures. Okay, an ability to recover from, adjust easily means some kind of, I can say like ability to recover from failures. Recovering from the failures is the meaning of resilience. So that's why they given the name as Resilience 4J. So here, same point, what we discussed and everything, they are discussing what is going to happen in between. See, this design pattern concept you can use in another regular core Java examples. I mean, not core Java, some other scenarios also. It's not like always only part of microservices point of view. That's what they are trying to say, how it will work and all. But don't worry about all these things. They are explaining each and every property, what is going to be done and everything. In core Java point of view also, you can do all these things. But in Spring, we are not going to write all this logic. Spring will give you framework solution. Yeah, if you come back here. So that is what I think. Before Resilience 4J, we have one more organization, one more third party organization being supported by the Spring Cloud for the circuit breaker. I forgot that. I'll give you the name. Now Spring Cloud, Spring Boot is supporting which organization, I mean, which libraries? Resilience 4J. Okay, with respect to the circuit breaker design pattern, they are taking help of Resilience 4J implemented solution. They included as part of Spring Cloud is Resilience 4J. Before Resilience 4J, they started providing, taking Resilience 4J from last 1.5 years or 2 years. But before that, there is one more circuit breaker solution is available. I forgot that circuit breaker. Anyone knows? I think no. Resilience 4J. Very bold, but nowadays it's nobody is using. I mean, Resilience 4J is better than the previous solution. That's why Spring is also supporting now Resilience 4J only. If you see everywhere Resilience 4J, I don't know whether I mentioned in the material or also not. No problem. It's not, I'm just trying to say like, for a design pattern, you will have solutions from different vendors, different organizations. So which solution is giving better, okay, output that you will use generally. I don't know whether I written here or not. Fault tolerance. This is all we are going to do now. Okay, I think I did not mention here. Forgot that name. But that is old one. Anyway, that's having little bit problems. That's why Spring Cloud also nowadays supporting Resilience 4J. So if anyone else is asking which circuit breaker you are using as part of Spring Boot means, you can say like Resilience 4J. I forgot that name. Okay, leave it, no problem. Okay, so anyway, latest we are using, no problem. So for that, if you see here, so I'm just taking help of document to take care of these properties, guys. Okay, no need to remember all these things. Don't worry about all these values, all these properties. I'll try to give you in a high level point of view. That's what I told you. Most of the times people are not using this solution. There are a lot of other challenges also with this solution. What is easy solution and all, we'll try to discuss. Okay, for example, scenario wise, I'll just implement very quickly. So what Resilience 4J is going to do, they are just explaining protecting our application from the cascading failures. That means all these things to improve the availability of your application, reduce impact of failures on the application, improve the performance, whatever it is. Now, generally this is expected response. When everything is bad, then you will get 500 internal server error when communication is failing. Okay, then what you have to do is you have to follow circuit breaker implementation now in case of failures point of view. So where you have to add these things, user service. That is what I also ask you same question. Where you have to provide the circuit breaker implementation. Okay, whoever is consuming, that's responsibility of consumer application. Okay, handling the failures from the producer point of view. You cannot ask the producer, why are you failing? Can you do something favor for me? Something like that, right? So you have to make sure your own arrangements with respect to successful and failures point of view. That is all. Similarly, tomorrow S2 is communicating with S3, some other service. Then what S2 will also follow same approach. Like that. Okay, let's go to I will stop all the services first. Okay, so now I'm just going to the user service. Okay, I forgot to tell you one more point. Okay, we discussed it, but only thing is technical I did not tell you. So what circuit breaker is doing internally? When it is moved to the open state in the backend, it is keep on monitoring or not? Monitoring for the health status of the opposite application as well as it is keep on monitoring for success response from the opposite application point of view. Okay, how do we know health status of one application? For example, I have a Spring Boot application. I would like to know health status of Spring Boot application. We discussed on solution. Actuator, yes, exactly. So if you are added actuator dependency to say your Spring Boot, you are having a predefined URL called as what it is? /actuator/ actuator is correct, but there will be an URL, right, to know the health status of application. /actuator/ health. Health only. The endpoint itself, /actuator/ health. We discussed all these things. Spring Boot actuator. See, this is what I'm asking. Okay, so what it will do is internally that Resilience 4J or circuit breaker implementation to monitor health status of any other applications. Yeah, actuators is a good. Yeah, Netflix Hystrix. Yes, Sri. Okay, thanks. Yeah, Hystrix is the old one. So before Resilience 4J, Spring Cloud or Spring Framework is to support Hystrix solution. That is from the Netflix. But after that, they found Resilience 4J is giving better results when comparing with the Hystrix. So that's why Spring Cloud is supporting now onwards Resilience 4J. Okay. So yeah, health is good. Thanks, Jacob. Okay. So internally, the circuit breaker concept is always using identifying the health status, all these things. So that's why when you want to implement circuit breaker status, circuit breaker design pattern on any microservice, you have to make sure that microservice is okay, health status. Okay. You have to make sure actuator dependency also. You have to make sure adding the actuator. Internally, it is taking help of actuator. Simply, I can tell that. Okay. So what I will do, here it is. So Spring Boot actuator, we know what is actuator and all, we already discussed. So internally it is taking help of somewhat AOP functionalities. So if you want to add this starter, you have to add these two dependencies also manually in a circuit breaker point of view. What you can do is just copy paste into pom.xml file. You can add from here also. You can check from here, circuit breaker, all these things, then it will come. Instead of that, you just copy paste from here for this module. So theoretically, if you remember the how it is, see, circuit breaker, what Spring is supporting now? Only Resilience 4J, they are not supporting Hystrix. Circuit breaker with Resilience 4J as the underlying implementation. They are working with Resilience 4J. Spring taken Resilience 4J code and they customized related to Spring point of view and they released as a this solution. But this is not a good solution also sometimes. I'll discuss that once we are done with the implementation. So I added 3 dependencies now. Actuator, AOP, as well as Resilience 4J. Yeah, it's getting building. Okay, fine. Okay, so this is what the configuration we have to add now. So what is this configuration? We will try to understand with respect to user microservice level. So I'm going to the application or properties. You can add this configuration inside the config server also related to where in your specific microservice properties file. You can do that or you can add from here also, no problem. Okay, so you know what is this management? No? Don't say no. We discussed. Okay, so at least I will discuss with respect to actuator. Okay, it's not there in the running material, running notes, but we discussed it. In the actuator time, what is the default endpoint available when you added actuator? There you will see when you are studying about the actuator will provide. Actuator is giving a lot of predefined endpoints. The default endpoint is, they are enabling only one endpoint by default. What it is? Health only. Apart from that, what you know? Slash loggers, slash mappings. I shown you guys, I remember. I shown you how many controller objects created, right? When you entered slash mappings, actuator slash mappings, then you will see all the request mappings information with respect to the actuator point of view. But by default, it is enabled. So this is what actuator means, health, like that. We do have so many other endpoints. Please remember, these are all very important interview questions. Most of the people will ask Spring Boot actuator. Yeah, beans, environment, yes, good. So I think you're on the inline. Thanks. Health is default one. We discussed all these things. I opened this at the time. Beans, it will display how many beans available in the runtime memory point of view. It will display what are the logger levels. Okay, being what are the loggers is enabled in your application, it will display. Mappings, what it will display? All your SREs mappings. I shown you this. But these are all things automatically enabled, by default enabled, except health, nothing will be enabled. So for that, what you have to do? You have to use this management.endpoints. We discussed all these things. Okay, only thing is in running nodes, we don't have it. But if you go to the project, what we implemented at the time of actuator, it's there. In the material also, it is there. Don't say like it's not there. We discussed also. So that is what I am asking about management now. So you have to make sure enabling, okay, what should be enabled, what should be disabled. If you given star, exclude, include, we discussed all these points in the actuator time. So go through it. That is what these three points, these three related to now what? These three properties related to which one? Actuator. So by using this, you are saying like management of circuit breaker, health status, enabled endpoints. Okay, you are enabling health status. So something like these are all properties related to health status. Yeah. So if just understand this, don't worry too much about it. Circuit breaker point of view here, you are giving in which microservice you are providing this configuration. This is all about circuit breaker configuration ID. You can give anything here. You can give any ID name here. This is all common. Resilience 4J circuit breaker instances. In user microservice, you are doing the configuration. So here you have to give one unique ID that has to be maintained. This is all comes under the circuit breaker ID. Okay, so you can give ABC, XYZ also, not only microservice name, but maintaining the consistency. That's why I given service ID, but we can give any name. So here, just understand the properties, register health indicator. So in the circuit breaker point of view, the health status of the application will be, okay, registered. If you see here, failure rate threshold is all about percentage point of view. Minimum number of calls, 5. So that means I can move this property to up. So here, with respect to the circuit breaker configuration, you are saying like minimum 5 number of calls has to be monitored. When failure is happening, then out of 5, if it is reaching threshold percentage 50%, that means how many calls? Out of 5, what is the 50%? 2 or 3. If it is reaching third call, then it is going beyond 50%. Then your circuit breaker will be open. So that is what the threshold. It's all about percentage value, but we should not give percentage here. But the value what you provided here, it is out of 5, 50% threshold is reached, means 3 calls are reaching. Then it will move from closer to open state, something like that. Okay. So similarly, wait duration in open state 6 seconds. So it to open. From moving to open to half open status, how many seconds time it has to wait? That all you are giving the configuration here. It is 6 seconds. Maybe in why you given 6 seconds here it is. Sometimes it may respond. Okay, you are just waiting some longer time, whether the opposite application is responding or not, something like that. Okay, like that, you given permitted number of calls in half open state. So I told you already. Yeah. So in half open state, it is always moving, okay, monitoring upcoming service request getting success or not. So that is what it is all about. Request successful with threshold value. So that is what the point here it is saying. Permitted number of calls, half open state. So sliding window size is all about here. The window size, sliding window type count based here it is. Thus, okay, here, the point here it is, where it is. Yeah, here. So the number of moving from one status to another status is all about happening, depends on the count, 3 calls, 4 calls, something like that. They given all these solutions. That's what I'm telling you. Don't worry about all these properties very heavily. Just try to use these properties, copy paste into your application, but understand when circuit breaker default status is what, when circuit breaker will be moved to open, when it will move to the half open, when it will move to the close. If you are able to remember theory point of view, that's more enough. No one will ask you in interviews, what are all these properties? Never ever will happen. Because the reason is, first of all, This is the solution not being used in many of the microservices architecture. So no developer knows, even developer knows, they can also cannot remember all these properties. It's very difficult. Okay, so let's add it. All these things with respect to user service point of view now. Okay, fine. Now, I made only circuit breaker functionality added to user microservice. What about the fallback mechanism? That means what about the response? When circuit is open, I have to see until whenever failures are happening, instead of seeing that internal server error, all these things, I have to see a meaningful response or not. Right? So then where I have to define the fallback methods, what I have to do, okay, to get this meaningful response in the failure status, what I have to do is fallback mechanism we are trying to do now. So this is what we have done now. Configuration of circuit breaker. And at the same time, we have to provide a fallback mechanism in case of failures, falling back mechanism. That means sending a meaningful response, okay, with respect to failures time. So for that, what you have to do? So for that, we will define fallback method. Okay, here you are going to use some circuit breaker annotation and I'll tell you where you have to do all these things. Simple. If you go to user microservice, let me open service class also. Okay, what is the REST service we are triggering here? / create order, right? So this user service, REST service internally calling order service, REST service, right? So what is the origin of API here? It is origin means starting point. This is the starting point or not? So that means if you go to the user controller, yeah, here, this is the REST service, right? This is the REST service is internally calling the, yeah, let it be open. Yeah, internally calling order service, REST service, right? So in this class level, sorry, in this REST service level, from here initiating the service call. This is the controller endpoint of belongs to what? User microservice. There is no, there is no discussion about order service. I did not open anything related to order service. So this is the origin point, okay, with respect to user microservice to call the order microservice. Client will call, so that means client means postman, for example, in this case. Now postman, from the postman client, I am sending a request. Then it is reaching to here. Then from here it is reaching to order microservice. So what the circuit breaker here it is saying, here it is, there you have to use an annotation called as circuit breaker. And as part of this annotation, you have to define fallback method name. And you have to give some method name here. Anything. Okay, so create order. Failure, something like that. So this with the same name, we have to create a method also. I'll show you that. Okay, so see here, just understand, very simple. You are adding a annotation. Why you are added here? Where you are initiating the, okay, the origin point from the current microservice. Okay, where it is, okay, from where, sorry, which REST service of your current microservice is calling the REST service of other microservice. So this REST service is making the call to other microservice. So that's why what you are doing, you are adding a circuit breaker design pattern, sorry, circuit breaker annotation here. So when you can see this annotation without adding the dependency of circuit breaker resilience 4J, can you see these things? Now you added the jar files. That's why you can see now. So, and you are saying like where you are adding, what is this name? Circuit breaker name. So where you configured in the application.properties, I told you, right? This is the circuit breaker ID. If you given ABC here, then what you have to give here? Okay, sorry, here I will explain first here. Then you have to give here ABC. If you given their user-service, then you can give user-service. So this is the name, this is the value of the application.properties level, what circuit breaker you are using. So you can create similarly another circuit breakers also with another ID. Can you create one more circuit breaker? Yes, then you have to do some other IDs, all these things like that. Circuit breaker 1, circuit breaker 2. So one REST service point of view, you can use one circuit breaker. For another, see, for example, user communicating with the payment point of view. Payment point of view, you need a different configuration, circuit breaker point of view. Then what you will do? You should not use this configuration for payment microservice communication. Then you will write down one more configuration like this, user hyphen payment. Then where you will use this? Here it is all about user hyphen something like order service. Now, for example, tomorrow, if we go here, controller, yeah. So in this, what you are doing? You are calling which REST service? Payment application REST services, right? For example, see here it is payment microservice calling. Here it is order microservice calling. For example, your requirement is demanding the circuit breaker configuration, what you use for other microservices is not being used. For payment point of view, you need a separate configuration. Then you can create one more circuit breaker with circuit breaker ID. Now, what is the fallback method? What is the circuit breaker name you will give in this case? In case if you written here @circuit breaker, then what is the circuit name you will give here? User hyphen payment you will give. So you got the point. So that is what you have to do. So that's why I told you, you can give any name here. It is circuit breaker ID. Okay. Yes. In our case also, circuit breaker we given name as user hyphen service only. Go to the controller class. Okay. First I'll give name equal to, what is the name? This is the name. Okay. So when circuit is opened, based on this configuration, when failures are happening, immediately this method has to be executed. This method has to be executed. For that, they given fallback method as a attribute. Okay, you given here what? Method name. So with this, you have to create a method here now. So with the same method name should be same. Okay. So here you have to pass. What is the return type? What is the return type of actual REST service? String, right? So you can take same thing here. Tomorrow, for example, assume here it is somewhat order related. Then you can define some dummy order information, or you can manipulate the response message also. Okay, here, let me do one thing, public. And one more rule here it is, we have to define an argument of exception class. Okay, so why you have to define this exception argument type here it is? Failure means generally exceptions are not. Why it is failed and all. So it's all about exceptional case or not. So if you want to see why, what is the reason services got failed in the logs level, if you want to see the trace, then that's why circuit breaker is recommending always a exception object as part of the method argument. So what you given here it is only method name. But here method argument, one of the method argument what you have to pass immediately is an exceptional class object, exception class object. So that's why if you see here throwable is also family of exception or not. So let's take throwable, topmost one. You can give exception also, no problem. Okay, returning problem. Okay, so here I'm writing like order hyphen service or order service is not responding. Please contact support team or whatever it is. Okay, so you need to take throwable argument here because you can print. Okay, sorry, I forgot to do that. This is for the tracking purpose. What is the reason why this fallback mechanism coming into the picture? What is the exception reason? You will come to know that. That's why it's mandatory defining this. Dot get message or localizer message, whatever it is. You can print as it is object also. Get message, something like that. Okay, so this is what you have to do. Adding the dependencies, creating a circuit breaker configuration, how many calls, minimum calls, threshold performance, okay, all these things, and then where you are creating where you are making a circuit breaker call, then you have to do. For example, tomorrow, payment point of view, you have to maintain the failures. What you will do? Again, you are going to write down. For example, if you want to use same circuit breaker, you can use it. Okay, same configuration. Simply you will write down @circuit breaker, name equal to user-service and followed by fallback method. You will write down one more fallback method. Here, something like meaningful payment, make payment failure or payment service failure or whatever it is. Payment service is not responding, something like that. You will write down one more fallback method and you will define that method name as part of the fallback attribute. You just try that. Yeah, so that is all. So simple fallback method you define, and this is where you are defining the response, what response, your meaningful response and everything. Okay, this is the circuit breaker configuration you are taking. Now let's start the execution point. This fallback mechanism coming into the picture or not, we will try to see. Yeah, this is all I'll show you right now. Actuator health. See, for that properties, I opened this. Save it. Okay, I'm starting config server, gateway, service registry first. And I'm starting order also. I'm starting user also. First, we will see what is the default status of circuit breaker. When both are up and running, getting actual response, order created successfully 200, okay, all these things. Okay, so then we will see that. Don't worry too much about the circuit breaker. I'm only telling you. It's being asked 1 or 2 questions, very rare case in interviews. What is the idea behind circuit failures, how you are managing? That is one reason. One thing is you can tell this. And second thing, I'll not show you, but I'll tell you what you have to do. You already know that. I'll tell you that. Try to implement and you can answer that one also. Okay, so user started, order started and everything is good. Just wait for 1 minute. Because internally, service register is taking all the information. It will take some time, booting time. Yeah, user is running, order is running. So let me send the request. Yeah, it's not up and running. That's what you have to take some time. Yeah, so now you got what? The actual response or what? Actual response from the producer application called as order-service. The request went successfully to the order service level, executed successfully. The response generated in the order service level, and it is came back to the user microservice. Okay, service communication is success in this scenario. So if you keep on sending, as of now, order service health status is good. It is working as expected. Everything is fine. Order created successfully. Let me open an URL. So localhost. Okay, if you see here, what is this? Actuator endpoint, health endpoint. The circuit breaker, they are internally integrated. The circuit breaker status, everything related to this endpoint point of view. So this endpoint we know or not? This is what we discussed in the actuators time. So that's why go through the actuators. It is one of the important not topic with respect to interview point of view, one of the important concept. Okay, so just go to actuators. We discussed very well. In material also it is there. Okay, so if you see here, generally, if you don't add an actuator, circuit breaker, are you going to see all these things? When you send actuator/health, you will see only one word called as status up in our previous discussion or whatever it is. Now it's all about related to circuit breaker point of view. If you see here, circuit breaker status up, leave it. This is what we most important thing. State is, default status is, state is circuit breaker state is closed. Let me send the request, send. So observe, refresh it. Okay, if you observe here, failure rate -1, failure threshold 50% what we configured, buffered calls to something like that. If you are keep on sending, in the back end, it is keep on monitoring the health status of the, okay, the service communications happening successfully or not. So there is no failures. That's why still it is on the closed state. So it is showing from where property is getting loaded from the GitHub. For this microservice, user microservice, it is loaded properties from the application.properties user service. They are displaying a lot of other details also. Services, order service, user service. In this case, what is being involved? Discovery client point of view. Okay, it's not like that. Okay, now let me stop order microservice. Yeah, I'm just stopping order microservice now. Yeah, it is stopped now. Let's go and verify. So why it is still closed? We are not sending request to order service as of now. We are not sent. When it will move to the open, it will observe 1 or 2 calls getting failed or not. If it is failed, 2 calls, then threshold is reaching third call time. It is reaching to the 50%. Then circuit will move to the open state. Okay. So let me send the request now. 1. So see here, order service is not responding. Please contact support team. Okay. Still closed state. So fallback mechanism coming into the picture or not? And at the same time, if you observe here, why state is closed? Somewhere something is missing. Yeah, it's see here now. I think we given count is 10 something is there. So state open. Now after 6 seconds, it will move to the half open and it will keep on monitoring the failures also. If you see here failure rate 50%. When you are sending n number of calls, buffer calls 8 we given, failed calls 4. In the 5th call level, it is moved to the open state. So that is what failed calls it is observed 4. So then it is moved to the open state. Now let me refresh it. It moved to the immediately it will move after 6 seconds. We given 6 seconds as a moving to the half open state. So now in the half open, it is keep on running. Okay, so it is keep on. Circuit is half open now. Okay, so this is what it is doing. Now, fallback mechanism coming into the picture like this. Now let's start the order service also. Simple guys, it's all about getting meaningful response with respect to service failures is all about the concept of it is. Instead of getting so and so service is not respond 500 internal server or all these things point of view, you have to see this kind of meaningful message by the client. So the client will take a decision what they have to do. What okay like that. Now if I started order microservice, yeah, it's taking time. Internal it has to register with service registry, everything. Still half open state. Okay, if you go here, order created successfully, still half open. It will monitor 2 or 3. Okay, success scenarios also. Half open, third, fourth. So it moved to the closed. We given you just give less number of values here, then you will encounter very easily. Size 3, something like that. Size 10, 4, 5, something like that. It will become very easy. Now, okay, so you understood now? Internally, circuit breaker is taken care of, bringing into fallback mechanism. When service are failure, instead of sending all the the meaning errors, factors, all these things, you are sharing a meaningful response back to the client in the failures time. That is what the agenda of circuit breaker design pattern. Don't think too much about the how circuit breaker is operating. The agenda of here it is what? How we are managing service failures. How we are sharing response back to the client in failures time. How we are sending meaningful response. That is what the agenda here it is. Now, can you guess and tell me, for example, I got an exception. See, for example, in earlier case, what exception you got? Before circuit breaker, when your order service is failed, order service is stopped, we sent request. What exception you got? Internal server error, something you got like client not responding, fin client not wrong. So it's an exception or not? Right? So now can you tell me with your knowledge, whenever I got an exception with respect to Spring web application or Spring Boot web application, instead of displaying all the exception information, I want to make sure displaying a meaningful response. Then what you will do? Sorry? Exception handling. What you will do with respect to exception handling? Controller advices. So you can define your own exceptions, user defined exceptions, predefined exceptions as part of the controller advice. What methods you will write down? Exception handler methods you will write down, right? So you can write down in the controller class level, or you can write down a separate global exception handling called as @controller advice level, right? Yeah, exception handler. This is what controller advice. This is what we did, right? We discussed all these things. Arithmetic exception, how you are handling, writing controller advice classes, all these things, right? We can handle it in global. So now, if you don't have circuit breaker, okay, so generally what will happen? You will maintain some timeout where you are calling the actual REST service. Where you are calling here, right? Here only you will get the exception or not? Because here only, right? Finally, you are calling the REST service. So in this line only, you will get the exception or not? Right? So whatever the exception you are getting, timeout exception or whatever the exception you are getting. So if you are writing exception handling, throwing exception from here, then it will reach to. If you are throwing whatever the exception you are getting here, if you are throwing that exception, it will reach to where? Controller advice. Then controller advice level, you can handle this exception with meaningful response messages as well as status codes also, right? You can set response entity as part of the controller advice classes or not? We discuss. It's there already. Running notes point of view also see here. I'll show you the code. We written already. So that's what I told you. Whatever I discussed is 100% is really important with respect to real-time applications or upcoming topics point of view. Controller level exception handler, we discussed all these things. So what you are doing in the exception handler method level, you are sending meaningful status codes or also not. You are making a meaningful message as well as you are making meaningful status codes also. So that much of customization you are having with the circuit breaker, fallback method level, sending all these things. So that's why there will be solutions. It's not like that solution is being used by every application automatically. No. So this is what people will do. Now in my current project, we are doing same thing. In every microservice level, when service failures are going to happen, we are writing one user defined exception class, something like service failure exception or something like that. Some global, okay, we are writing a exception class. Whenever user is calling sometimes payment, sometimes order, sometimes delivery, sometimes some other. From user is calling from the order 10 to 15 microservices, 10 REST services from the order microservice itself. Then how many fallback methods you will write down? it's very difficult, right? Managing every failure with respect to each and every REST service point of view is very difficult, right? And that too in the back end, it is using what? Actuator. It is using always actuator. So in the back end, the circuit breaker is keep on polling for the health status or not. If you implemented circuit breakers for all the microservices, then what will happen? Performance issues will come or not. In the back end, something is keep on monitoring, something is keep on running a process. In every microservice point of view, a process is running like monitoring point of view. Such failures happening, success happening, like that, keep on monitoring something. That is comes under the process or not. So a process is running, that impact the performance or not, right? But in real-time applications, in production environment point of view, I'm telling you, very rare case, a service will go down. Very rare case, a services will go down. That is how the production environment, they will configure with high-end configurations, with a number of instances, and that production environment is keep on monitored by the DevOps team. By writing some DevOps tools, they will keep on monitor. When a service status is going down, for example, one service is going down, immediately within seconds or within minutes, okay, a mail will be triggered to so many people. Like so and so service is going down to the support team, to the management team, to the development team, something like that, or to the DevOps team, something like that. Then immediately they will take care of restarting that service and making that service is available. That means in real time production environment point of view, service failures are percentage is very, very less. Okay, I can say like 99% never ever services will go down once you made it at the production environment level. Once it is available in the production environment level. So when failure is very less than 1% with respect to service health status, but unnecessarily you added circuit breakers, health status checks, all these things in the every microservice level, then what will happen? Performance degradation will happen because in the back end a service is running or not. And that too you added actuator. Actuator is not recommended to add most of the microservices because actuator will expose other mapping informations, beans information, couple of other properties information. See, it is exposing what from where, from which GitHub also it is. Your properties are loading. This is also it is exposing or not. Right? These details are automatically exposing or not. So that's why people will think all these things when they are using any solution in the project. It's not like blindly they will use it. They will consider so many factors, security, performance, is it really required or not? Do we have any alternative solution or not? Which is giving better result, which is going to give better performance. Sometimes, even though it is giving better result, but if it is okay, making a problem, or maybe if it is making a chance of security problems, then people will not use it. Because you have to consider everything. Security aspects you have to consider, performance you have to consider, everything they will consider, and then only they will go with the solution point of view. Okay, so in my application, what they are using now? Kind of exception handling. Wherever service failures are happening, there we are writing a exception class with, okay, you know how to create user-defined exception, right? So same way we are also created exception classes, okay, some with lot of other properties, a reason why it is failed, string message, status code, integer value, something like that, to whom it has to contact, something like that we return some kind of meaningful exception class, and that exception we are throwing whenever failures are happening. And that exception message finally reaching to the global exception, and then it is preparing a meaningful response entity, that response finally coming back to the client level as 500 order service is not responding, please reach out to so and so team or something like that. We are getting a meaningful response. In this case, we are not at all adding any circuit breaker dependencies, any fallback mechanism. Fallback mechanism we are achieving with the exception handling or not. That is what, right? Exception handler also giving the same message, order not responding, something like that, right? So that is how things will happen. So that's why I'm telling you, with respect to interview point of view, just go through the circuit breaker, practice 1 or 2 times going through the material, but don't worry too much about the properties. Don't think too much about the circuit breaker also. I'm only telling you, but what you have to worry more about the microservices architecture. Service register is definitely 100% interview level point of view or even real time point of view. Gateway is the first and foremost important thing. Second thing is service register is the first and foremost, second important thing. After that, config server also couple of people are using, couple of people are not using. Yesterday I told you. You can talk in positive way, you can talk in negative way. In my current project, what we are using? We are not using config server. We are using specific to microservice. We are configuring all microservices properties in that microservice itself. We are not worrying about the other services being used this property or not. If I change here, it may impact to other microservice or not. So those are all problems are avoided in my current architecture. So that is all. But couple of people will use config server like they will feel like, okay, we will take care of things very carefully, but we will maintain everything at single place. Like that couple of people will think. So that is what config server is somewhat important, I'm telling you. And apart from that, communication, microservices, communication. Thin clients is the most important topic because there what you are avoiding, port numbers, all these things, dynamic routing to the respective producer application point of view also. You are not depending on the port numbers. You are eliminating entirely port numbers, dynamic routing with respect to n number of instances. Okay, when you are having so many instances where you have less instances, it is always happening dynamically. Load balancing point of view, all these things. So load balancing is coming as part of the service registry. So that's why also service registry is the main component being used in every Spring Boot microservices architecture applications. Okay, so this is all about the microservices architecture or microservices topics. Okay, so I'm telling you, these are all just being commonly asked or commonly used in every application with respect to my current organization, previous organization, couple of projects I observed from my colleagues, friends, or whatever it is. Whenever we are keep on discussing what they are using as part of their project, what we are using, these are all the common things where you have to focus your knowledge. And first and foremost thing is, don't worry too much about the microservices architecture. Worry more about the core Java. Your interview always starts from the core Java. First 10-15 minutes will decide whether you selected or not. A panel will be decided first 10-15 minutes itself. After 15 minutes, whatever the questions we are asking is all about time consuming. That means we will have a rule, something like that. We have to take interview for 30 minutes minimum. HR will define a rule to us like some organizations will define a rule like you have to take interview minimum 30 minutes. But I will decide whether you got selected or not within 5-10 minutes itself. First 5-10 minutes, I will decide you are answering properly or not, you are selected or not. But why I am going beyond 10-15 minutes is, again, I have to satisfy with the HR team. So we have a rule like we have to take minimum 30 minutes. So then I will ask questions until 30 minutes and I will say like, I'm done with interview. But your selection thing is done in initial 5-10 minutes itself. I will feel, okay, selected. After that, whatever answers you are saying, some kind of yes or no questions are maybe wrong answers, but you will be selected. That means the impression will come in the first 10-15 minutes only in most of the times. First 15-10 minutes itself, I will realize this candidate is good or not. Technically, practically, all these things point of view. So, but first thing, in any interview, if you go, 95%, the hierarchy will start always from the questioning always starts from the core Java only. So if you are not good with the core Java, in 10-15 minutes, if you are not doing well with the core Java, then your impression got rejected. Then even though you are good with the other things, your failure will, always you will be rejected in the interviews. But make sure, step the hierarchy point of view, core Java is strong. Spring Boot, microservices. When you are good with core Java, when you are good with Spring Boot, and 1 or 2 questions you are not answered from the microservices architecture, 100% you will be selected. 100% I'm telling you. Panel will never think like you should answer 100% everything. Panel will think like what I am asking being answered very well with respect to a couple of questions or not. In a practical manner, you explain very well or not, instead of by-hearting manner. If you answer first 10-15 questions in such a way, whatever you know very clearly, if you are able to deliver or if you are able to explain, then panel will decide, okay, this guy is having very good knowledge of practical things. He can understand very easily. He can learn on very easily. Tomorrow, even though if you got any new area, he can get knowledge very easily. He can understand very easily. Something like that panel will understand. Like that, I selected so many people. Okay, not only me, even when you are sitting together with other colleagues or team leads also, they used to do same thing. Sometimes we used to join 2-3 members on the same panel. I will not ask any questions. My team lead will ask, or I will say like, you can go today. So he will ask couple of questions. First 5 minutes itself, we both will discuss. Let's select him. First 10-15 minutes, he will say like, okay, seems to be is good. Let him select. So then we will ask couple of other questions also. But the decision making happened within 10-15 minutes only. That is how everywhere will happen. Even if you going and looking for anything, purchasing or whatever for your own purpose, what you will do? You will see first 10-15 minutes or something like that, right? You will decide whether you want to go with that option or not, something. Same thing here also. Panel is also nothing but a human only, right? So make sure your hierarchy is always starting from the core Java. If you are weak in the core Java, you will never ever get a job also. Because, sir, please update this project in Drive. Yeah, I will update Sai Pavan today. Everything I will upload. Okay. Okay. So that's why please make sure hierarchy. So that's what you will get interview calls very less. But whatever the call you got, they will start always from the core Java. Observe 90% panels will ask always starts from the core Java. That is the hierarchy. Yes. That is the way only we have to ask. So that's why please make sure core Java is strong and then Spring Boot. And I told you in case if you want to maintain parallelly both the practice at a time, both the knowledge at a time, what you have to do? Yesterday I given you a suggestion also. Make your requirements are some larger requirements. Take n number of JSON objects as a request payload, filter those values in the service layer, what is being missed, what is being not missed, what is being missed, send those to the database, something like that. You have to create your own requirements. Someone else will not come to you and they will not increase your potentiality. They will not increase your performance. It's all about your self responsibility. Okay. So apart from this, that's what I'm telling you. With respect to interview is different. Doing job is different. Getting job is very difficult than doing the job. Okay. Because why? Interview is all about instant. You have to answer instantly for the solution for the problem. But job, you will have some time. They'll give you, okay, by end of the day, complete it. They'll give you problem. They will tell you like complete by end of the day. Then what you will do? You will Google it. You will do the ChatGPT. You will recollect your knowledge. You will collect it to you call to your friends or whatever. But in interview, it's all about instant. Within 10-15 seconds, you have to respond back. So that's why interview is the most difficult process. Okay, when we are trying to get the job, and once you are getting the job, you will have time. You can easily work on anything once you are good with practical knowledge, all these things. From where you will get instant help. See, most of the times your senior people will help you guys. Okay. So, but they should realize like you are keeping sincere efforts. I have to feel like you are doing the sincere efforts with respect to your fresher knowledge or fresher person or something like that. If I understood like, okay, this guy is keeping sincere efforts, but unable to make something progress, then I will come back and I will say like, this is how we have to do, this is how we have to do that. But when I realize like, this guy got the job unnecessarily, this guy is, okay, unnecessarily he got the job, he is not doing anything, he is doing other things, then even though you are trying to looking for the help, seeking for the help, no one will try to help you. They will understand this guy is useless. Okay, don't help him like that. So your efforts should speak. Then automatically people will come back to you. They will start helping you and they will make you more progress. They will only teach you a lot of things, how to do, what to do and everything in the project point of view. Okay. So that's why please keep your efforts everywhere. What is dialect? I'm not taking this. This is already done in the JPA level. Okay. So tell me how to search a job. Best way to find Ankita. So that's what guys, nowadays job market is not good. Even though if I'm saying n number of factors here, nothing will work. It's all about it. Nowadays the things depends on the luck. I don't know which people are getting the calls from the panel, which are not getting, we cannot able to predict. That is how the market is going. But few people are getting automatically sometimes, few people are not getting, even though they are doing so many things, they are not getting the calls. Few people are simply uploading the call, resume, they are getting a couple of calls, something like that. But my point here it is, make sure your resume format is good and updated all the skills what you learned till today. And in the Naukri profile, LinkedIn profile also, what you can do is update your skills very clearly. What you know, Spring Cloud, Spring Boot, something like that. Yes, you can do that. Spring Boot, Spring Cloud, Spring Boot, Spring Cloud. Okay, Spring Cloud Gateway, something like that. Microservices, you can define all these things and make sure your resume also somewhat better than other resumes. So your resume should explain everything, whether you are having knowledge, whether you are, what is the stack you are having, technical stack, that should speak. But market is not good, I'm also telling that. But once market is going to be good, by the time if you are not ready, then what you will do? So that's why don't lose your efforts. Market is somewhat not good, but simply silent hiring is happening with respect to references. People are getting placed in the companies nowadays, but external hiring is not happening that much actively. So this process still is not like a lifetime process. At one fine day again, this situation will be closed. Again, you will see the demand for the software engineers. Okay. So then by the time you should be in the front row to get a job or to get the more money also. Okay. So market is not good. I'm trying to say that one again. But at the same time, it will not be a lifetime situation. It will be again back. For example, if you take in 2008, 2007-8, there is a lot biggest recession happened. 2008 also there is a recession happened. Then so many people lost their jobs. So many people didn't get the jobs. Whoever is having jobs, they also lost. Okay, lot of recession in the US, India, or wherever it is. But after that, slowly it got adjusted in 2010 and 11. It took 2 years. Again, 2011 time, the market is boomed like anything. So all my seniors got problems with respect to getting IT jobs when I'm studying MCA before that. But once we completed MCA by 2011, once we entered into the market, almost all my friends got placed within 1 year or 1.5 years in every, whoever is tried sincerely. Yes, I'm sure 95% of people here will not write. I'm sure. You will say, yes, we know. But whenever I ask you actuator / health, nobody is saying like / health is the end point. You forgot about actuator also. That is what the problem with you, most of the people. Don't do that. Revise. Okay, revise the things. Whatever I discussed in the class, whatever I told you, everything is really important with respect to your interview point of view, with respect to real time job point of view. Okay. For business techniques, this is all about business things happening in every software industry, especially in service-based companies point of view. That's why they will always look for the experienced people. And whenever you are having gap, try to keep the experience. Nothing will happen. Okay, you will get a job. All my friends, including me also, I got a resume irrespective of programming. For example, assume they are working on the Python language. You just take that project name, project description, keep in your resume, keep technology stack as Java. That's all. So understand that flow. That's what I'm telling you. In interviews, they will not ask more questions about your project. 1 or 2 questions they will ask. What is your project flow? Can you explain me? You will explain 2 minutes. Then immediately they will jump into core Java, Spring Boot, all these things. They will not ask what is your project, who is your client, what is your client name, client manager, where it is located. 99% no one will ask. Okay, so you can do that one. Spring material, I think I already uploaded. I'll upload if you want one. I will verify today and I'll upload everything. If it is not there. My experience, when I'm trying with experience, how I got project. So we have to keep one project in your resume with fake experience, right? From last 3 years, I was working on this project. So how I got the project? I just went to the Google. I searched for a lot of resumes. Java 3 places experience of resume, something like that. Okay, I found a couple of resumes and I found one of the project from those resumes and I kept it. Okay, so when demand is there, everything will be executed without any problems. Even if you are uploading rough notes, rough paper also on the Naukri, they will hire you when demand is there. Okay, so everything is possible. So just try with your efforts, keep up your efforts and make sure practically you are good. Your practical speaking will decide you whether you are selected in the interview or not. It should be always in practical. Don't dependent on the theory. Okay. So anything else you want from my side?